maybe the atomic masses are making some more sense to you. Go to page 8 of the notes, and I want to take a look at hydrogen. Now, I'm going to tell you a couple of things. This is stuff that you would be told. 99.985% of the hydrogen in the world is hydrogen 1. And a whopping 0.015% of it is hydrogen 2. What would you think the atomic mass of hydrogen should be closer to, 1 or 2? All right, I know this is one of the more difficult questions of the year, but take 5 seconds and talk to your Schmoes Pair partner. You don't have to move, and then ask them and decide. Did you get 2? Good, because 2 would have been the wrong answer. So 1, yes, clearly, 99.985% of the hydrogen is hydrogen 1, so clearly it should be closer to 1. Let's take a look, and it is indeed 1.0079. Perfect, okay? Calculating that's not so hard. I'm going to show you how to calculate it for carbon, and then you have a worksheet that you're going to do some other examples with, okay? So let's look at carbon. We're going to derive the atomic mass. 98.89% of the carbon in the world is carbon-12 with an exact mass of 12.000 AMU. The other 1.11% is carbon-13 with an exact mass of 13.003. These exact masses actually take into account the electron masses as well as the slight difference in mass between a proton and a neutron. They don't weigh exactly the same thing. In fact, neutrons are just slightly heavier. So for these calculations, we'll use these exact masses that we're given. Derive the atomic mass of carbon. Well, the equation is just, right, frequency, just like we were doing right before. Frequency of the first isotope times the mass of the first isotope plus frequency of the second isotope times the mass of the second isotope. Forever, as many as there are, and that equals the atomic mass. So let's apply that to this example. I'll do this one with you, and then you're going to be on your own in just a moment. So you have to convert the percentages into decimals, which is just moving your decimal over 2 to the left. You got to change them into decimals of frequency rather than a percentage. But the same kind of idea. So 0.9889 times 12 plus, now careful with the single-digit percentages, 0.0111, right, times 13.003. And what do you get? I have to go calculate that. You work on that while I work on this. 0.9889 times 12. That's 11.8668 plus, no, you don't have to show this amount of work every time. I'm just making it easier for myself. You can. It's not the end of the world. 0.143333. And you add that up, and you get 12.0111333. All right. Now to the right number of sig figs, of course, you'd have to stop at 12.011 because you have 3 decimal places on the addition, and that's it. Okay. So match that up to what's on the periodic table. And oh my goodness, it matches up perfectly. Okay, so that shouldn't maybe be too surprising. You can imagine on you're ever assessed on a question like this, I have to see work because otherwise you can just look them up and get the right answer. And that's not okay. So what you're going to have to do now, an individual, I'll let you work in your group of 4. I want you to do these other 2 examples involving boron and nitrogen now. Okay, press pause, let people go ahead and do that. Okay, I'm hoping that you went and looked and you saw that you got about 10.8 for this second one and about 14.0067 for the other one, and those match up remarkably well with the masses on the periodic table. So what you have left to do for today is just doing an atomic mass worksheet, and you should be in business for that. You will have a quiz on atomic on this chapter coming up shortly. Got to figure by Tuesday. Okay, I would think that you'd have a quiz on this chapter while we start working on electrons, which is the next chapter, naturally chapter 13. We do have one more page. It's just a brief introduction to the periodic table. There's not much to say here. I'll briefly mention it, that the periods are the rows, that the columns are the groups, and that this staircase right here is really important in that it separates metals from nonmetals. And the one thing I want you to be able to do for me when we go over this is the last thing I want you to do before you go off to the worksheet, is that I want you to be able to know which side is metals and which side is non-metals. And before you get totally freaked out and like asking how you're supposed to know that, well, I got news for you. All the metals are on one side and all the non-metals are on the other. So all you need to do is have a favorite metal and then see what side of the staircase it's on. Have a favorite non-metal. See what side of the staircase it's on. If you can do that, you're going to be golden. So I'm going to be calling on people randomly on Monday who's, I'm going to say, all right, Kyle, what is your favorite non-metal? And Kyle's going to tell me whatever it is. I don't want to put any words in Kyle's mouth. So Kaya is then going to be asked, what her favorite metal is. And she's going to tell me. And I'm probably not going to call on either of them. This way, everybody's ready to do it. So have a favorite metal and a favorite non-metal so that you can always know which side of the staircase they're on. It's pretty much all that's on this page, a little bit more, but not much. And then it's chemical bingo time, and then that's it for the chapter. So we'll have a quiz on this chapter before we go on to chapter 13, at least too deeply. We'll probably start chapter 13, but blah, 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 whatever. Bank on Tuesday for a quiz, and you'll get the Atomic Mass worksheet now. Thanks for watching.